Data is the new oil, and you too can tap into it. It might also be replacing your job soon, so you need to position yourself not to be a victim. You may have questions like, what is data science? What is the work of a data scientist? What skills are required to be a data scientist? What are the challenges of becoming a data scientist? How do I become a data scientist? At Southgate DataNet, we answer all these questions. We lay a foundation for what it takes to be a successful data scientist, with lots of projects and hands-on exercises to build your confidence. To start your career as a data analyst, sign up by visiting www.sgdatanet.ng/sign-up. For more information, send us an email info@sgdatanet.ng or call +234 808 226 3768. Data is the new oil, and you too can tap into it. It might also be replacing your job soon, so you need to position yourself not to be a victim. You may have questions like, what is data science? What is the work of a data scientist? What skills are required to be a data scientist? What are the challenges of becoming a data scientist? How do I become a data scientist? At Southgate DataNet, we answer all these questions. We lay a foundation for what it takes to be a successful data scientist, with lots of projects and hands-on exercises to build your confidence. To start your career as a data analyst, sign up by visiting www.sgdatanet.ng/sign-up. For more information, send us an email info@sgdatanet.ng or call +234 808 226.
Welcome everyone. Welcome. You're welcome to today's journey.
Thank you.
You're welcome. Hope the holiday has been nice. Today is the holiday, public holiday in the country. So that was why I decided to move it forward instead of 7 p.m. as usual. So you're all welcome. Today we are still learning on data analysis. You know, we want to be data. The aim is to make us data geeks, data experts.
Amen.
So we started some weeks ago, and we've done quite some few topics in R. I'm sure by now we are familiar with what R is, because we have installed it, because we have seen me display it on the training slides. So today we are moving. I'm taking it step by step, little by little. You see that most times I don't take long hours. I try to make it as short as possible so that you can catch what I'm doing. So today we are moving a step further. We started with defining what R is, those who use R, why do you even think of using R? Because there are so many other statistical tools there. We said R is free, R is open source, R has collaboration from different people, so it gets stronger and stronger, you know. And a lot of reputable companies like Mozilla, like Facebook, like YouTube, they use R in one form or other. So today we want to learn about
I
this.
think you also mentioned that R can easily be updated because it's an open source.
Yes, open source. Yes, I said that. That's why I said that it's free, open source, because a lot of people can contribute to it. You know, it's a community.
It's always up to date.
Yes. So you can see the version of your R when you come to help and you click about R Studio. So this is version 1.2.2.5.0.2. 2009. It started 2009, this version, and it's been updated to 2020. That's like 11 years.
Yeah.
So this is the GNU license. You can read more about the GNU license, you know. So it's You can see how updated it is. You are not left alone when it comes to R. When somebody develops a new package, it's available and you can come here and search for the package and install. This is the package area. So we all know that it has four segments. This is where you type your code. This is what we call the console, the second one. This is what we call the environment, where your data and your variables are. So your variables are assigned to some data, which are normally numbers. So these are your variables and these are the data they contain. And this is where I said you can see packages. This is when we start plotting graph in how you will see your graphs that will show here. Then help, if you want to read more about anything, you can come here. But I think you need to be online to be able to do this. So we started with some data types in R when we started equating some numbers to some variables. So variables, when you hear me say variables, it means it's what is storing my data. My data must be stored in something. It cannot just be existing in the cloud. It must, in the computer, you must assign it to a variable. So what that data is 9.1, it's assigned to a variable, which is KP. Variable is called variable because it varies. I can get to line 14 and change that KP to 10. You see, it varies with time. As the programmer is typing, it varies with time. So it's not constant. It's only constant as of the time when it is assigned to that value. When I get to another line, I can change it. So we talked about the integer. This one is storing what? Numeric, because it has decimal point. Then we also talked about the character data type, like this one, storing learning R is fun. You can see this one is storing alphabets, a mixture of alphabets, making a sentence. It can be as long as you want, and it's quite different from the ordinary numeric data type because it has a quote, opening quote and closing quote. So when you are using a character, or we call it, some people call it strings or character, anything that is not numbers is called a string or a character. We need to put them in quotes. Then we talked about other data types like logical data type. This was where we used the logical operator less than or greater than. Then after we learned this, we moved on to data structure. We left data type and we came to data structure. Data structures is just like data type also, but they store more data than data or a single data type. You know, a single data type, you can only store one value, but in data structure, you can store multiple values to a variable. So that is a data structure. So we talked about vectors. We started talking about vectors. Vector stores the same data type, like if it's numbers, if it is integer, it's going to be integer around, or if it is, and we assigned it. And what allows us to do that is this C that is called operator. Then we can do a lot of calculation and manipulation on our vector. All right. So we move to another data type called data frame. I think that was the last class we did. Then I don't know.
Okay.
Yeah, that was the last class we did. I don't know if we've been able to install R on our laptops.
Yes, I have R.
Oh, that's good. That's good. I don't know if we've been able to type some of those codes into it. And did we get it, or was there any problems we encountered along when trying to do it? So today we are going to another data structure called list. List. We are going to talk about list and matrix. List and matrix. So before we go there, let me just explain it in the manual. So we're talking about list and matrix. today. Arrow vectors, it should be matrix. All right, so list and matrix. It's another data structure. So today, we are going to learn what is a list and a matrix, how to create a list and a matrix in R, what can be done with a list and a matrix in R. So list is a collection of vectors of equal or unequal length. If you remember in data frame, when we talked about data frame last week, this is data frame. We said data frame is a collection of vectors also. We declared some vectors up here, which are these ones. Then we created a data frame calling, this is how to declare a data frame, assigning the data frame to records. Like I assigned it to records, and I use the word data.frame, and I put the vectors inside. But you will notice that the vectors do have equal length, isn't it? They have equal length. But in today's, if you count the number 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, they are all equal length. But the difference between a data frame and a list is that a list are a combination of vectors also, but they are not equal length. That's the difference. They are not equal length. So you could, if you look at my screen now, you could have a vector like n equals to this, 2, 3, 5, s, another one equals to a, b, c, d, e, then another one, b, equals to true, false. You can see that the lengths are not equal. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 1, 2, 3, 4. Whereas this one is 1, 2, 3. So if you want, if you have a record of unequal length, it's better to use a list for it. That is what you should do. If you have a vector with unequal length, if you have a record, so there are sometimes you are not sure whether your Excel sheet has the same length or for each columns. In that situation, just declare them as a list. Whether they are equal length or not, as long as you have declared it as a list, it will work. And even if there are some missing values in some rows in your Excel sheet, it will still work. So that is when to declare a vector. And this is the command for declaring a vector. You will say list, that's very easy, it's even the simplest. List and put a bracket and all the vectors you want. NSB. Then you can add a new value. Like I added, this 3 was added here. So after the B, there's a 3. So that is how to declare a vector, a list. Then the last one we are going to look at today is called matrix. Matrix, I'm sure in secondary school, in secondary school, is it secondary school I did matrix? No, in university we did something like matrix, 100 level.
In statistics.
In statistics, yeah. So matrix is a 2-dimensional regular layout. It can be 2-dimensional, it can be 2 to 3-dimensional, depends on number of columns and rows. So they call it n by n. N by n. So the syntax is very easy. I want you to just focus on the part that has the other the equals to. For instance, this my.matrix is equals to, the command for matrix is this. There will be matrix, which is the function that will create the matrix for us. Then there will be 1 column 10. That means the number of values I want to be in the matrix. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the number of elements in that matrix. Then how many columns will your matrix have? This one is going to have 5 columns. And how many rows will the matrix have? We're going to have 2 rows. So 10 elements, 5 columns, and 2 rows. So this is how your matrix will be displayed. So I'm going to go to the R code and we are going to practice some examples. So for the list, I have declared a vector n equals to 2, 3, and 5. I separated them with a comma. Then another vector s, a, b, b, c, c, d, d, e, e. This is a character data type, isn't it? Because it has alphabets. Then the last one, b, it's true, false, false, which is a logical data type. So to declare my list, I now created a new variable called x and assigned it to this list. Then I display the output. So let me run this code now. I highlight it and click the run button. So if you look underneath at the console, you will see my list being displayed here. Then if you look at the environment also, you will see it has stored all the elements. You can see n has 1, 3. That means it has 3 elements. And the elements are 2, 3, 5. Then S has 5 elements. The elements are this. Then the B, which is the logical, has 5 elements too, which are these. So, and X, this is X, which is my list, is here. So this is how a list is displayed. Then the other one we talked about is matrix. So even in this, before I go to matrix, I can come here, comma, and put 7, comma, put 0, comma, put 9, and run it. What do you think will happen? If I add 7, comma, 0, comma, 9 to this list, do you have an idea of what do you think what will happen here? Does anybody know?
The list will change. The values. I don't know.
Okay, let me run it so that let me display my X. Yeah, you are right. So what happened was that if you look at the output here, instead of it stopping at the B, it continued. The 4th element is 7, the 5th element is 0, the 6th element is 9. So that's what it did. So the list increased. It increased. Then
so that was possible because it wasn't list can accumulate not just one what do you call it when it has different numbers of unlike unequal this thing.
Yes, yes. It can accommodate as many unequal length for each vectors.
Okay.
Can accumulate unequal lengths. So it doesn't matter. Even in what happened here was that even in this list, I added new elements, which are not assigned to any vector. You know, they are not assigned to any vector. I didn't come here and declare another vector, y is equal to 7, p is equal to 0, 9 is equal to 0. No, I just added it and it allowed it. So that means in a list, when you have a list, you can add elements into it as you like, even if they are not assigned to any vector.
Vector. Thank you.
So matrix. Remember the formula for creating matrix? So this is my variable neo underscore matrix. That is the variable that I'm assigning the matrix to. Then for you to declare a matrix, you must use the matrix keyword. just like we use list. Then you put your element. How many values do you want your matrix to have? Here, I want it to have 1 to 10. That is why I put that. Sometimes you might have a vector already. So here you can put the vector name here also. Let's say your vector is this one, you can also put it here. You understand? But when you are putting a vector, always make sure, let's say the vector is already existing in your code, maybe in some lines, maybe line 10 or something. Make sure that the vector, the rows, columns and rows, that vector can accommodate it. So for instance, if your vector is this now, and I go and put n here, and this one I just have 3 elements, definitely it can't work with this, because how many rows can I get? How many columns can I get from this? Maximum columns I can get is 3. So I decided to use this. So that is why you need to. But you can see, to save myself stress, I just put the values here, the number of columns I want, the number of rows I want, and I run the code. Let me run this code now. Yeah, so if you look down, you can see my matrix here. So row 1, this is column 1, column 2, column 3, column 4, column 5. How do I know it's column 1? You know, columns have X and Y axis. So X is the row, Y is the column. So you can see that there's a comma here. That comma, there's no value in front of the comma. So that is telling you that if there was a value, that means that's the row. But there's no value. So it means that all this 1 and 2 here is column 1, is column 2. If you look at this one for row, remember we said it should have how many rows? 2 rows. So it just has 2 rows. You can see 1, 2. And the comma is after the row number. So row 1 has 1, 3, 5, 7, 9. Whereas column 1 has 1 and 2. So this is how to declare a matrix. Very easy. This is how to declare a matrix. So this is my matrix. When I click on it from my environment, it shows here. Can you see? This is the matrix. All right. So I want to perform some manipulations. I want to turn a list into a matrix. I want to turn a data frame into a matrix. Remember we did data frame last week. So this is my data frame. How do I convert it to a matrix? It's very easy. I have this data frame, line 12. I want to convert it to a matrix. So I give the matrix a name, next.matrix. And I said is equals to as.matrix, and I put the data frame inside. So automatically, this data frame that you see here is going to be replaced with what? Everything that is here, you know. So to convert it to matrix. And you can also check the, so this one, let me run it. It will not display anything, but it's going to convert it to a matrix. Let me display next.matrix. I want you to display it. All right, so this is my next.matrix. It's just 1 row, 3 columns, 2 columns, 1 row, isn't it? 2 columns and 3 rows, which is 2 columns and 3 rows. That's what the matrix turned it. That's what the matrix command turned it to. So I converted a data frame to a matrix using as.matrix. Then if you look at line 15, I said to find the data type of the second column in the data frame. How do you know what data type is the second column in the data frame? This is the data frame we are talking about. The command to use is this. even if it's not a data frame or if it's an ordinary data type, and you type class, class will tell you the class of data type it is. All right, so you will use the command class, then the data frame name, then the $sign, then B. So this is the second column. This is the first column, right? First column, and this is the second column. And you want to know the class of the second column, and you have to type this command. You might not do this often. Tell us that it's numeric, which is true, because everything here is numbers. This is the, when we turn it to matrix, this one will be the first column, 1, 2, 3, 1, 2, 3, and this will be the second column. That is what we are seeing here. A has 1, 2, 3, B has 1, 2, 3. All right. Then the second command are to find the data type of the second column in the matrix. Of the second column in the matrix. This is the second column. Now we are talking about matrix. This is the second column here. The B. What is the data type of all these columns? This is the command you will run. Class, I told you, class is for detecting data type. Then you put the matrix inside. Matrix is next.matrix. Then you put, because it's the column we are looking for, we put 1. Supposed to be 2. 2 is the second column. Then I run it. Character. Okay, let me say the first column. Character. So what happened was that everything was turned to character. So this is how to do some simple manipulations in matrix. There are much more manipulations you can do in matrix actually. This is just telling you, giving you baby steps on how to work on matrix. We can do addition, we can do subtraction, we can do multiplication, you know, we can get some elements out of the matrix and all that. So today we are bringing it to an end for today's class. I hope you learned something.
Yes.
Okay, so what I'm going to do, I will send the script to your mails or then and the videos so that you can run it yourself and get the same output I'm getting. Is that okay?
That's fine, sir.
All right. So do you have any question?
No question. Apart from, I think you mentioned that already, but just keep my mind what character actually means.
Okay, character means alphabet.
Male or female? Okay, alphabet.
Yes.
Okay. All right. Thank you.
All right. So thank you for your time. We'll come your way on
That's all.
Friday. Have a wonderful evening and bye for now.